Construction is everywhere, from the homes we live in, to the offices we work in, to the highways and bridges we travel on. It shapes our daily lives in ways we often don't even notice. And yet, construction also carries a huge responsibility. In 2025, the choice we make in building design and construction aren't just technical, they're environmental, they're social, they're economic decisions that affect the entire planet. Buildings today are responsible for nearly 40% of global energy consumption and a similar amount of greenhouse gas emissions. The materials we use, the methods we use, and even the location of our buildings all contribute to the impact that we leave on the Earth. Sustainable construction isn't just a trend, it's a necessity. Perhaps the most urgent reason for sustainable construction is climate change. Every concrete wall, every steel beam, every glass facade has a carbon footprint. In fact, cement production alone contributes to around 8% of global CO2 emissions. And when we combine that with the energy used for heating, cooling, lighting, the building sector becomes a major driver for climate change. Sustainable construction aims to minimise these emissions. That means using low-carbon building materials, recycling where possible, and prioritising designs that reduce energy demand. By building sustainably, we can dramatically reduce the contribution of new construction to global warming. But it's not just about carbon. Sustainable construction also considers resilience. Rising temperatures, extreme storms, and floods all threaten poorly designed structures. By adopting green standards, architects and engineers can create buildings that withstand the climate challenge of 2025 and beyond. So, sustainable construction is about more than carbon. It's about using resources responsibly. Traditional construction consumes vast quantities of raw materials, steel, cement, timber. Well, they're all energy intensive to produce and often require destructive mining and logging. But by choosing sustainable materials, builders can reduce the environmental impact. For example, using reclaimed or recycled steel and wood, low-carbon concrete alternatives, and innovative materials like bamboo, hempcrete, or cross-laminated timber. It's also about efficiency in design. Buildings that use materials wisely. Structurally optimized walls, floors, and frameworks require less material to achieve the same strength and functionality. The result is less waste, fewer emissions, and a smaller ecological footprint for every new structure. And resource efficiency isn't only good for the planet, it also encourages circular economy principles. Materials can be reused at the end of the building's life rather than ending up in landfills. Even if a building is constructed with low-carbon materials, it can still consume massive amounts of energy during its life. Heating, cooling, lighting, appliances, they account for most operational emissions. Sustainable construction addresses this by designing energy-efficient buildings that minimise ongoing demand. Some of these strategies include passive design, such as orienting buildings to capture natural light and heating. High-performance insulation, like reducing heat loss in winter and heat gain in summer. Smart systems, like using sensors, automatic lighting, and efficient HVAC systems. Renewable energy integration, like solar, wind, and geothermal power on-site. The result is a building that uses far less energy and has lower emissions over decades, contributing significantly to sustainability goals. Sustainable construction isn't just about the planet, it's about people. The buildings we inhabit affect health, comfort, and productivity levels. Things like poor air quality, insufficient natural light, or toxic building materials can cause long-term health problems. Sustainable construction focuses on healthy, high-quality environments, using non-toxic paints, adhesives, and finishes, maximising daylight to reduce eye strain and improve mood, incorporating natural ventilation and air filtration, and integrating plants and biophilic design to connect occupants with nature. And the benefits extend beyond individual health. Schools, hospitals, and workplaces that are sustainably constructed have been shown to improve learning outcomes, employee satisfaction, and overall well-being. Finally, sustainable construction has tangible economic and societal benefits. Initially, some people assume that this will cost more, but research shows that sustainable buildings actually save money over time. For example, reduced energy bills, lower maintenance costs, and longer building lifespans make them financially smarter in the long run. Socially, sustainable construction can enhance communities. Green spaces, pedestrian-friendly streets, and energy-efficient public buildings. Sustainable infrastructure also supports resilient cities, able to adapt to climate events, population growth, and shifting economic needs. In short, sustainable construction doesn't just reduce harm, it creates value for both people and society, aligning environmental responsibility with economic sense. So why does sustainable construction matter in 2025 and beyond? Well, because it's the bridge between what we have built and what we will need for the future. It addresses climate change, conserves resources, improves human health and strengthens communities. And it's no longer optional. Every choice in design, material and construction methods have consequences. And sustainable construction ensures those consequences are positive rather than destructive. By building sustainably, we're not just creating buildings, we're creating a future that's safer, healthier, and more resilient. A future where architecture supports life rather than threatens it.